this lesson covers section 4.2 from the textbook and deals with graphing equations. So in the previous section, we talked about writing functions and how we can plug in values for functions, we can plug in other variables for functions, and in this section, we're going to talk about graphing those and making a pictorial representation of what those functions mean. So the first thing we need to start off with is what's called the Cartesian or the rectangular coordinate system. And it's called the Cartesian coordinate system because it's named after Descartes, who was the first to kind of come up with this grid system of how to map things. So, you've probably seen this before somewhere along the way. We define this to be the x-axis. So all of our x values lie along here. The other axis is our y-axis, and so this plots all the horizontal values of y. And we can find any point on this plane by just using the ordered pair. We talked about ordered pairs in the last section. The ordered pair of x, y. So they're always in these coordinates. And so we would go out and we would say however many x, if it's positive, it goes to the right. If it's negative, it goes to the left. And then we would find our y value. If it's positive, it goes up. If it's negative, it goes down. The other important thing to remember is where these two axes intersect is what's called the origin. And the coordinates for this are 0, 0. So this is both when x is 0 and y is 0. Where the axes intersect is the origin. Some things that are also helpful, which you talked about in Tech Math 2 and you will again in Tech Math 4, is that we can break this down into quadrants. Since there are 4, we call it a quadrant, quad meaning 4. And so this is quadrant 1. As we rotate around counterclockwise, we get quadrant 2, 3, and 4. The other thing to keep in mind is the signs of each ordered pair or each x and y value as we go around in these quadrants. In quadrants 1, everything is positive, so your x value is positive, your y value is positive. In quadrant 2, you're over here on the negative x side, so you've got a negative x value and still a positive y value because you're on the top part. If you look in quadrant 3, they're both negative because you've got negative x values and negative y values. And in the fourth quadrant, you're back to having positive x values, but now you have negative y values. And so we've got this combination of all of the possibilities of combinations for positive and negative x and y values. So when we talk about graphing, we also need to remember a specific term, which is what's called a one-to-one correspondence. And a one-to-one correspondence in mathematics is when a given element in the domain has a corresponding element in the range, meaning that every input has exactly one output and that every output has an input getting to it. So usually when we talk about this, if we draw the circles again and we put in our elements, we'll call them 1, 2, 3, 3, and 4. And our outputs, this is our domain, and our outputs are the range. Then we get A, B, C, and D. Then each element here goes to exactly one element in the range, and each element in the range had exactly one element that got it there. So this is how we go through and plot points. I've given you some kind of graph space here, and you can put in your own axes. I'm going to just choose to kind of put them in the middle here. I'll make this a little bit bigger so we can see it. And I'll put it in about the middle here. And the thing that we always want to make sure that we do is to label our graph. So we've got the x-axis and the y-axis, but even more important than that, we want to make sure that we have each one of these grid marks labeled. So if we know that this unit here is 1 or 10 or 1500 or a half, we need to make sure that we define how big this graph is. So I'm going to define this to be 1, and I'm going to define this here to be -1 for each unit there. Like I said, you can make whatever units work for your graph. Sometimes you need it to be by 10s or 2s or 100s, depending on the scale of your graph. The other thing to keep in mind is that the x and y axis do not have to have the same units, but the entire x-axis does. So if you make the x-axis go by 2s in the positive direction, in the negative direction it also has to go by 2s. But you can have the x-axis go by 2s and the y-axis go by 10s, and that's perfectly fine as well. You don't have to have them have the same numbers, but all of x has to be the same and all of y has to be the same. So if we go through and plot some of these, if we wanted to plot, for instance, the point A, which was 3, 1, then again, these are x, y coordinates, so we would go right 3, 1, 2, 3, and up 1, and this would be our point A. Next, if we wanted to plot B, we would go to the right 2, and then since it's -3, we would go down 1, 2, 3, and we would label that as B. For C, we would say we've got -1, so we're going to go to the left 1, and then down 4, 1, 2, 3, 4, and we get point C. And then for point D, we go back 2, and since our y value is 0, we just stay on the axis. For E, we've got -5, so we're going to go left 5, 1, 2, 3, 4, 5, and then up 2. So we end up with E there. And finally, F is the point 0, 5. So 0, we don't move left or right. And then we go up 5. 1, 2, 3, 4, 5. And we have to always make sure that we are careful to do these in the correct order. First, we move left and right. Then we move up and down. So we can use this to plot and graph various equations and various functions. Sometimes it's easier to plot actual points, and we'll do a few examples with that. Sometimes when it comes to straight lines, it's just easier to do what's called the slope-intercept form and follow that, and that's perfectly fine. So for this first example, I'm just going to plot a few points. And for a straight line, we need to pick at least 3 points, just to make sure that we haven't made any errors. Because if we plot 3 points and they're not in a straight line, then we know one of the points was off and we need to go back and recalculate. So it's up to you which points you want to pick. It really doesn't matter. It's just how you want your graph to look, where you want it to be situated. Some people like to be nice and symmetric and pick the points -1, 0, and 1. Some like to pick 0, 1, and 2. Whichever you prefer, it's up to you. So for this one, if we plug in -1, y of -1 is going to be 3 times -1 minus 1, which is going to be -3 minus 1, which is -4. If we plug in 0, we end up with 3 times 0 minus 1, which is just -1. If we plug in 1, we get 3 times 1 minus 1, which is 3 minus 1, or 2. And if we plug in 2, we get 3 times 2 minus 1, which is 6 minus 1, or 5. And so again, it's up to you which points you picked. I put 4 up there, but you need at least 3. So if we put in our axes again, and we'll go with the middle here, we'll kind of keep it symmetric. So we'll put in our axes here. And the reason that I didn't put in axes for these, because I want you to be able to adjust them if need be. If you have a lot of positive values, then you can, positive y values, then you can just put the axis all the way on the bottom, and that's fine. So with this example, they were relatively symmetric, so I put the axes in the middle. Now, if I go and plot these points, again, we need to make sure that we label our graph so we know how far or how big each one of these units are. So if you can't want to, you can put them up here. You can put them down here where I did before. Wherever works for you, because this is kind of graph paper. But we want to make sure that we label them in some fashion so that we know how big each unit is. So in this case, we've got x is -1, so we go left 1, and then y is -4, so we go down 4, and we plot that point. And then we have the point 0, so x doesn't move left or right, but the y value is -1, and we plot that point. And then we get the point x equals 1, y equals 2, so that is right there. And the point 25, so we go right 2 and up 5. And if you notice here, these are all on a straight line. So if we can connect these dots, we should see that we get a straight line with them. And so all the points were correct. We're okay there, and we get our graph. Something to keep in mind when you're dealing with straight lines, and you probably covered this in Tech Math 2, is that if you have a positive slope or a positive value in front of the x, it's going to be increasing from left to right. As you'll see in the next example, you've got a negative number in front of the x, so it's going to be decreasing from left to right. If you do know the slope-intercept form and the way to graph this, all you have to do is pick the -1, which is our y-intercept. That's the point 0, -1, plot that. And then you can use the slope, which is rise over run. So in this case, it's 3, so we rise 3, 1, 2, 3, we run 1. Rise 1, 2, 3, we run 1. And we end up with those same points that we plotted. So I want you to pause the video and graph example 18. So for example 8, depending on which points you chose, I just used the same values that we did in the last example, which was -1, 0, 1, and 2. You should get the outputs of 6, 4, 2, and 0 with those. And if you plot those again, notice I moved the x-axis down a little bit in this case because we did have that 6. I wanted to make sure that it fit on the graph. So in this case, again, if I plotted my points, I've got the point -1, 6, 0, 4, 1, 2, and 2, 0. And if I connect those, I get a straight line. Again, in this case, we had a negative slope, the -2. So it's decreasing from left to right. And again, if you wanted to actually use the slope-intercept form to graph this, you would have started at the y value of 4, which is right here. And then you would have gone down 2, 1, 2, and over 1 to the right 1, down 2, and to the right 1, and you would get those same values. So that would be how you would graph some linear functions.